Hello, Namaste. I am Gauss. Today my topic is binomial theorem. Binomial theorem also we call as a Newton's formula. In this Newton's formula, in this binomial theorem concept, we can take a two terms. That is, x is a one term, a is another term. These two terms we call as a binomial. X plus a whole to the power of n. N is the exponent. Here, what about n? N is a exponent. In this exponent, n is a positive integer. Okay. What about x and what about a? X and a are the real numbers. X and a are the real numbers. Okay. Now we want to do this x plus a whole power n expansion. In this expansion, we already discussed about the Pascal triangle. First of all, in this expansion x plus a whole to the power of n, for example, we have this x plus a whole cube. What is this expansion x plus a whole cube? In this binomial Pascal triangle, we can take this first one is binomial 1 1. We can add this both coefficient ended by 1. 1 plus 1 is 2. Next, both end with 1. 1 plus 2 is 3. 2 plus 1 is 3. Here, last both ended with the coefficient 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Is this? We can apply this is suppose x plus a whole to the power of 4. How we can read right now? X is first, x is now decreased by 1, x is decreased by 1, a is increased by 1, a is increased by 1, x is a decreased by 1, x plus a whole to the power of 4, 4 is the exponent here. This is the first we can write here x power 4, x is decreasing, that is x power 4, next x cube, next x square, next x. Whenever x cube here joining a square, a cube, a power 4 bounded by 1. So the coefficients is 4 and this is a 6 and this is a 4 and this is a 1. This is a 1, 4, 6, 4, 1. We call as a binomial coefficients. See here also we can take x plus a whole power 4. In this combination x plus a, in this combination x is decreased by 1, a is increased by 1, but x to the power of 4 first here, but in this 1, 4, 6, 4, 1, these are called binomial coefficient. In this binomial coefficients, now we want to write now NC0, NC1, NC2, NC3. These are called binomial coefficients. First you want to write here, start with NC0. So x power is here, highest power is 4. So here highest power is n. What about this condition? X is decreased by 1, a is increased by 1. Say x power n plus next comes NC1. Here x power 4 decrease here 1, that is 4 minus 3 is 4 minus 1 is 3. Now here x power n minus 1 joining here a plus NC2 x power now decrease by 1, same n x power n minus 2 a square. Same procedure if you want to write this is following the by using Pascal triangle concept only NC0 x power n plus NC1 x power n minus 1 a plus NC2 x power n minus 2 a square plus NC3 x power n minus 3 a cube and so on. Now here write NCR x power n minus r a power r plus and so on. This is a procedure going on, and last term is nothing but NCN x power n minus n a power n. See In this Pascal triangle concept, first term coefficient and last term coefficient bounded by 1. Same procedure here also we apply this condition. What is the first term here? First term coefficient is NC naught, last term coefficient is NCN. Before going to this, here we can say here NC naught, NC1, NC2 and NC3 and so on NCN we are called as binomial coefficients, right? They are called as a binomial coefficients. They are called as a binomial coefficients. Okay, this is the binomial coefficients. Next we are going for conditions. What about this condition? First coefficient and the last coefficient bounded by 1. We can see this NC naught value is 1 and NCN value is 1 only. First and last coefficients bounded by 1 only. Yes. Next, see in this concept we can take here NC1. NC1 value is nothing but NC1 value is N. NC1 value is nothing but 1. Suppose 3C1 value is 3, 4C1 value is 4, 5C1 value is 5. So we can write NCN value is N. Rest. Here NCR, see here NCR, we have one formula NCR. That formula is nothing but N factorial by N minus R factorial into R factorial. This is the formula. What is NCR formula? NCR is equal to N factorial by N minus R factorial into R factorial. What is the binomial theorem? Once again, x plus a whole to the power of n. X is the term is decreased by 1 and a is the term is increased by 1. Okay. Before we recall this total concepts, NC0, NC1, NC2, these are called the binomial coefficients, right? X power n is the highest power of the coefficients. Each power must be is equal to highest exponent value. N minus 1, this is the 1. N minus 1 plus 1, this is the n only. Next, how many terms here? How many terms? See, okay, again we can discuss these concepts. How many terms in these concepts? Okay, now we are going for the concepts briefly. For example, x plus a whole square. How many terms in these concepts? X square. Next, 2ax plus a square. That means here power is 2. How many terms we have? We have 3 terms. That means highest coefficient is 2. Now we are required here how many terms here? Total terms is 3. That is 2 plus 1, 3 terms. Same as x plus a whole cube. How many terms here? X cube plus 3x square a plus 3x a square plus a cube. First coefficient, last coefficient bounded by 1. Okay, this is how many terms here? Here exponent value is 3. Exponent value is 3. Total 3 plus 1, that is 4 terms. 1, 2, 3, 4. We have these 4 terms. So in this concept, x plus a whole power n, in this expansion, how many terms we have? That is number of terms. Number of terms is nothing but n plus 1 terms. So x plus a whole to the power of n. In this expansion, how many terms we required here? They are having this number of terms is n plus 1 terms. Okay, so this is the concept for this binomial. Number of terms of in the expansion of x plus a is nothing but n plus 1 terms. Okay, before going to these concepts, what about C? C is nothing but combinations. C is nothing but combinations. In these combinations also we have the permutations. In this again one chapter in this concept. Combination and permutations, this is arrangements. So number of ways of the arrangements. This ways of the arrangements, we called as a factorial. This factorial, suppose n factorial. N factorial means this arrangement of n factorial means n into n minus 1 into n minus 2 into and so on 3 into 2 into 1. This is called as a factorial, n factorial. For example, what is a 2 factorial means n value is 2. 2 into 2 minus 1 is 1. 2 into 1. 2 into 1 value is 2. 3 factorial. What is 3 factorial? 3 into 3 minus 1 is 2. Next 1. 3 into 2 into 1, that is a 3. 4 factorial is nothing but 4 into 4 minus 1. So they are having this 4 factorial. The concept will be 4 steps back. 4 into 3 into 2 into 1. So 4 3 are 12, 12 2s are 24. S. What is the 5 factorial? 5 factorial go for the 5 steps back. 5 into 4 into 3 into 2 into 1. That is 5 4s are 20. 23s are 60. 62s are 120. This value is 120. Here we have one clear known about the condition 0 factorial is arrangement is 1. 1 factorial is also 1. Remember these two concepts here. 0 factorial is also arrangement is 1. 1 factorial arrangement also 1. Okay. So this is the going for the factorial condition. Why are you now discussing about this concept of factorial? See, this factorial concept is nothing but we have this condition NCR is equal to n factorial by n minus r factorial into r factorial. For this convenience, we are using this factorial condition. For example, how you can find 5C2? 5C2. Remember this condition 5C2 nothing but 5C2. See here 5C2 means here 5 factorial, that is n factorial, that is a 5 factorial by 5 minus 3, 5 minus 3, 5 minus 3, that is 5 minus 3 factorial into here 2 having, this is the 2 factorial, that is means 5 factorial by 5 minus 3, 5 minus 3, this is nothing but 2 factorial into 2 factorial. So this is the condition for using these concepts. Before going to these concepts, I can give for the another one directly simply method. 5C2 is nothing but 5C2 means we are having 5C2. 5C2 means 5C2. This condition I can write it directly. NC2 is equal to n into n minus 1 by 2 steps. N into n minus 1 by 2 into 1. 2 into 1. 2 steps. 2 factorial as this is the 5C2 means here 5C2 means 5 into 5 minus 1 is a 4 by 2 factorial 2 here 2 into 1, that is a 2 1s are 2 2s are 5 2s are 10. This is the concept. For example, you want to find out 8C3. 8C3 means 8 go for this 3 steps back. 8 into next step is 7 into 6 by 3 factorial. 3 factorial means 8 into 7 into 6 by 3 into 2 into 1, that is the 3 2s are 6, 6 cancel, 8 7s are 56. This is the, we can apply, this is the how we can find this factorial conditions for the convenience of. Another we have another one NCR, we have the formula NCR is equal to n factorial by n minus r factorial into r factorial. Also we have this NCR is equal to NC n minus r. This is also by using this the shortcut formula. This shortcut formula, this is the, for example 10C8. How we can find 10C8? 10C8 means you go for this 10 into 8 steps back. 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2. So 8 steps back. Before going to this concept, directly we can write a 10C, 10 minus 8. 10 minus 8 is nothing but 2, 10C2. So 10C2 means you can write a 10C2, 2 steps back. 10 into next step is 9 by 2 factorial, 2 into 1. 2 1s are 2 5s are 9 5s are 45. This is the concept for using this condition. Next, what is the term of this condition here? This is called as a general term. This is called as a general term. General term we called as a TR plus 1. TR plus 1 is a general term. That is a TR plus 1 is nothing but NCR x power n minus r a power r. This is the formula for general term. So this is the binomial concept. We can discuss about total binomial concept. We have total different type of concepts. Okay. So this is the binomial theorem concept. Again we can discuss. Thank you. Thank you.